Hello, welcome back to Beginning Algebra. Today we're going to continue building our skills at solving linear equations. I'm going to show you a four-step process that you can use to solve any linear equation, and we're also going to talk about equations that have no solution or an infinite number of solutions. And I'll show you how to solve equations that have fractions as coefficients. There's an easier way than the one we looked at back in section 2.1. So here we go. Now the thing you always have to keep in mind when you're solving an equation is that the primary goal is to isolate the variable. The strategy I'm about to show you will let you solve any linear equation with the least number of steps every time. You can solve linear equations without using this process, but you'll just use more steps than the way I'm about to show you. So step one is to simplify each side separately. Remember, the equal mark separates the left side from the right side, and they don't interact at all while we're simplifying. So by simplifying, we mean to use the distributive property as needed to clear any parentheses, and then clear any fractions, and then combine like terms. I'm going to show you at the end of this video how to clear the fractions. Step two is to isolate the variable terms on one side of the equation. This involves using the addition property of equality. As we've said before, if you have both variable and constant terms on both sides of the equal mark, then you should add the smaller variable term to both sides. And what this does is it guarantees that you end up with a positive coefficient on your variable term. And then you can add a constant to both sides to isolate the variable term. However, if you do not have both variable and constant terms on both sides of the equal mark, then just add whatever's necessary to isolate the variable term. Step three is to isolate the variable. So in this step, we simply use the multiplication property of equality to obtain a variable with a coefficient of 1. And step four is to check your work. So as we've done all along, you should substitute the value found into the original equation. Of course, if you get a true statement, then you can write the solution set, or if not, you should look back over your work for mistakes, usually a sign error, or you could just start from scratch and solve the equation again. So we're going to do several examples together, and I want you to keep that four-step process in mind as we go along. Now, step one was to simplify each side of the equation separately. So look at the left side of the equal mark and ask yourself if there are any parentheses that need to be removed or any terms that need to be combined. The answer here is no, and then do the same thing for the right side, and again the answer here is no. So we can move on to step two, which is to isolate the variable term. Okay, this is the variable term. So we want to get this by itself on one side of the equal mark. Therefore, we need to eliminate the plus 5. So the way to get rid of plus 5 is to put minus 5 on each side. So I'll just subtract 5 from each side, and then we combine like terms. Negative 6x plus 5 minus 5 adds up to negative 6x. On the right side, 17 minus 5 adds up to 12. Now step 3 was to isolate the variable. So we want to eliminate this coefficient of negative 6. So we should divide both sides by negative 6 and then simplify. On the left side, the negative 6's divide out, leaving us a coefficient of 1, which is what we wanted. On the right side, 12 divided by negative 6 is going to make negative 2. So we'll have x equals negative 2. Alright, our fourth step is to check our work. So we'll just copy the equation over and we'll put negative 2 in the place of x. And so let's see how this works out. Simplifying the left side, negative 6 times negative 2 is positive 12. And then 12 plus 5 is 17. So we got a true statement, and therefore we know this solution is the right solution. So we can say the solution set is negative 2. Now here's a practice equation for you to solve on your own. I hope you'll pause the video and try it. And now if you've done that, let's go ahead and work this one together. So step one, see if anything needs to be simplified on the left side of the equal mark or the right side of the equal mark. In this case, the answer is no. Step 2 is isolate the variable term. Our variable term is 2m, so we want to eliminate this positive 7. So I'll put minus 7 on both sides of the equal mark. That will leave us 2m on the left side and negative 10 on the right side. And then step 3 is to isolate the variable. So we want to eliminate this coefficient of 2. We'll divide both sides by 2. The 2's on the left side will cancel, and that will leave us m equals negative 10 divided by 2, which is negative 5. Okay, step 4 is to check our work. So we'll put negative 5 in place of m. That will give us 7 plus 2 times negative 5 equals negative 3. Simplifying the left side, we know 2 times negative 5 is negative 10. And we know 7 plus negative 10 is negative 3. So we get a true statement here, and therefore we know that the solution set is negative 5. Here's example 2, and you can see that this equation is slightly more complicated than the last one because this equation has both variable and constant terms on both sides of the equal mark. But let's still go through our 4-step process. Step 1 is to simplify each side of the equation separately if possible. On the left side, there are no terms that can be combined. On the right side, there are no terms that can be combined. So moving on to step 2, we want to isolate the variable terms on one side of the equal mark. Now this is one of those situations where we have both variable and constants on both sides of the equal mark. So our strategy is to eliminate the smaller x term. So I'm going to subtract 3x from both sides. And again, the reason we focus on the smaller variable term is simply to guarantee ourselves a positive coefficient on our variable term when we get to the next step. It would not be wrong to subtract 5x from both sides, but it would force you to have to deal with an extra negative. Okay, so let's combine terms on the left side here. 3x minus 3x plus 2 just gives us 2. On the right side, 5x minus 3x gives us 2x, and then we have our minus 8 still. Okay, now we've worked down to just one variable term, and we want to isolate this variable term. So let's add 8 to both sides. And that's going to give us 2 plus 8 on the left, which is 10, and just 2x on the right. Now step 3 is to isolate the variable. So we want to eliminate the coefficient of 2. So we'll divide both sides by 2. And then on the left side, 10 divided by 2 will give us 5. And on the right side, the 2's will divide out and give us x. And of course, that can be restated as x equals 5. Now, step 4 is to check our work. So let's copy 5 in place of the variable. We'll get 3 times 5 plus 2 equals 5 times 5 minus 8. Okay, carrying out the multiplications, 3 times 5 gives us 15, and 5 times 5 gives us 25. And then working the addition and subtraction, 15 plus 2 gives us 17, and 25 minus 8 also gives us 17. So we know our solution is right, and we can say the solution set is 5. Here is a practice one for you to try. If you had a chance to do that on your own, now I'm going to go through it with you. So of course this one is very similar to the last one we did together. We don't have any simplifying that can be done on the left side or on the right side. So we'll start by trying to isolate the variable term. So because we have both variable and constant terms on each side of the equal mark, we're going to focus on eliminating the smaller variable term. Negative 8 is smaller than positive 2. So let's eliminate this minus 8k. I'll put plus 8k on both sides. And now 5 minus 8k plus 8k is just 5. On the right side, 2k plus 8k is 10k, and we still have our minus 5. Now, still trying to isolate this variable term, we now want to eliminate the minus 5 here. So I'll add 5 to both sides. That's going to give us 5 plus 5 equals 10 on the left, and on the right side we get 10k. Now for step 3, we want to isolate the variable, so we want to eliminate this coefficient. So we'll divide both sides by 10. On the left side, 10 divided by 10 is 1, and on the right side, 10k divided by 10 is just k. So our solution is that 1 equals k, And of course, if it makes you feel better, you can restate that as k equals 1. Now for step 4, let's check our work. So we will copy our equation over and we'll put our solution in place of the variable. And now let's simplify each side. Let's do the multiplications first. 8 times 1 is 8, and 2 times 1 is 2. Now on the left side, 5 minus 8 is negative 3, and on the right side, 2 minus 5 is also negative 3. So we have verified our solution, and we can say that the solution set is 1. Now I think it will be a good idea for us to go through this one again, because I want you to see what happens if you decide to eliminate the 2k first instead of eliminating the negative 8k first. So this time when we go through it, let's start by subtracting 2k from both sides. On the left side, we'll get 5 minus 10k. And on the right side, the 2k and the minus 2k will add up to 0, and we'll just get negative 5. Now we want to isolate the variable term, so we will eliminate this positive 5. I'll put minus 5 on each side. That's going to give us negative 10k equals negative 10. And now notice that in order to isolate the k, we'll have to divide both sides by negative 10. So that's going to give us, again, k equals negative 10 divided by negative 10, which is positive 1. So you see we got the same solution even though the steps look a little different. But if you look back and compare the work we did on the last slide to this work, you'll just notice that there are more negatives everywhere. So again, the reason we choose to eliminate the smaller variable term is to keep us from having to deal with so many negatives. Now always remember that a variable can be isolated on either side of an equation. Sometimes the variable will come out on the right, sometimes it will come out on the left. It doesn't matter where the variable comes out. It only matters that the coefficient of the variable ends up as a 1. There are very often several equally correct ways to solve an equation. I'm just focusing on this 4-step process because if you use this process, it guarantees you the minimum number of steps. Here's example 3, and this is of course still a linear equation, but this is the first example we've done in this section where we have parentheses to eliminate. So let's start in step 1 by eliminating the parentheses, and then we will simplify what we have on the left side. So distributing the 4 here, we'll get 4k minus 12, and then we have minus k, and that equals k minus 6, because of course there's no simplifying to do here. Now looking at the left side and thinking about how we can combine like terms, we see 4k minus 1k would be 3k. So the left side gives us 3k minus 12, and the right side is still k minus 6. Okay, now we're back into that situation where we have variable and constant on the left, variable and constant on the right. So remember, the strategy in this situation is to eliminate the smaller variable term. So that would be this positive 1k here. So I will subtract k from both sides and then combine like terms. 3k minus k is 2k, and then we have our minus 12. And on the right side, k minus 6 just gives us negative 6. Now continuing with step 2, we want to isolate the variable term, so we will get rid of the negative 12. So let's add 12 to both sides. And that's going to give us 2k equals negative 6 plus 12, which is positive 6. Okay, now for step 3, we want to isolate the variable, so we want to eliminate the coefficient. So we'll divide both sides by 2, and that's going to give us k equals 6 divided by 2, which is 3. Okay, now let's check our work. We'll substitute 3 in place of the k. So 4 times 3 minus 3 equals 3 minus 6. Okay, now let's simplify the left side and the right side separately. On the left side, I see that 3 minus 3 is going to make 0. And then, of course, 4 times 0 is 0. So we have 0 minus 3 on the left, and on the right side, 3 minus 6 is negative 3. And so I think you can see now that we have negative 3 equals negative 3. So that's true. Good news. And that means our solution set is 3. Here's another example with a pair of parentheses that needs to be eliminated, But notice there is a minus in front of this pair of parentheses, so we need to distribute the minus sign before we start combining like terms. Distributing the minus here, we'll get 8a minus 3 minus 2a, and then on the right side we have 3a plus 1. Now still in step 1, we need to combine the like terms on the left side of the equal mark. We have 8a minus 2a, that's going to make 6a, and then the right side will not change. So we have 6a minus 3 equals 3a plus 1. Okay, now we have variable and constant on the left, variable and constant on the right. So let's eliminate the smaller variable term. We'll put minus 3a on both sides, and then combine like terms, we'll get 6a minus 3a minus 3, which is 3a minus 3. And on the right side, we'll get 3a minus 3a plus 1, which is 1. Okay, now continuing with step 2, we will add 3 to both sides to isolate the variable term, and that's going to give us 3a equals 4. And now for step 3, we'll isolate the variable, so we'll eliminate this 3 coefficient. We'll divide both sides by 3, and that's going to give us a equals 4/3. Now a lot of times students will be upset if they get a solution that's a fraction, because they'll feel like, well, I must have done something wrong, because if the answer were right, it would have come out a whole number. Well, that's not really true at all. It's perfectly fine for a fraction to be the solution to an equation. And what you need to do to reassure yourself is, of course, check your solution. So that's what we're going to do here. Let's put 4/3 in the place of a. So we'll have 8 times 4/3 minus parentheses 3 plus 2 times 4/3 equals 3 times 4/3 plus 1. Now, I know this looks a little bit daunting, but we know how to multiply fractions together, and it's really not that bad. Let's go ahead and multiply 8 times 4/3 and also 2 times 4/3. So we'll do that first. 8 times 4/3 will be 32 over 3, because remember we do top times top and bottom times bottom. And then I'm not going to distribute this minus sign yet. I'm going to do this multiplication first. So 2 times 4/3 will be 8 over 3. And over here on the right, this 3 in the top and this 3 in the bottom will cancel each other out. And that will just leave us here 4 plus 1. Okay, now I see that we still have grouping symbols here. So if you're strictly following order of operations, you might think, well, I'm going to have to add 3 plus 8/3 here, and that's going to be a little bit of work. But remember, we have the distributive property at our disposal, and I see that I have thirds out here and I have thirds in here. So I know already that I'm going to be able to combine these two terms if I can just get rid of these parentheses. So I'm going to use the distributive property here to distribute this minus. So we'll have 32/3 minus 3 minus 8/3, and we want to see if that's equal to 4 plus 1, which is 5. Okay, now look over here on the left and you see we have 32/3 minus 8/3. Since the denominators are the same, all we have to do is the subtraction in the numerators. So 32 minus 8 is 24. So that's going to give us 24/3 minus 3, and we want to see if that's equal to 5. And now we know that 24/3 reduces to 8. 24 divided by 3 is 8. And so now we can see that the left side is 8 minus 3, and the right side is 5. Of course, this is a true statement. And so now we can say that we have verified that our solution set is 4/3. Now let's look at example 5 together. So I noticed that on the left side of this equation we have some distributing that we can do, and on the right side we have some distributing that we can do there as well. So let's go ahead and do that. 4 times 4 would be 16. Then minus 4 times 3x would be 12x. So now we've got 16 minus 12x. On the right side we have 32, and now we're distributing this minus 8. So minus 8 times x gives us minus 8x, and minus 8 times positive 2 gives us minus 16. Okay, now all the parentheses are gone. The left side cannot be simplified, but the right side can be simplified because we have 32 and minus 16 as our two constants here. So of course 32 minus 16 is positive 16. So that's going to give us 16 minus 8x on the right side. Now we're in that situation where we have variable and constant on the left and also variable and constant on the right. So remember, when we're in this situation, we always choose to eliminate the smaller variable term. Of course, negative 12 is smaller than negative 8, so let's eliminate this negative 12x. So we'll add 12x to both sides. That's going to give us on the left 16, and on the right that's going to give us 16 plus 4x. Okay, now remember, we're always trying to isolate our variable terms, so the thing to do now is to eliminate this 16. We'll say minus 16 on both sides, and on the left side that's going to give us 0, and on the right side we have 4x. And now we're going to isolate our variable, so we're going to need to divide both sides by 4. And then on the left side we can see that 0 divided by 4 is 0. And on the right side, of course, the 4's cancel, and we can see that we just have x. So it looks like we're coming up with a solution here of x equals 0, which is a perfectly fine solution. 0 can be the solution to an equation. Let's just check it and make sure that it really is the right solution. So we'll put 0 in place of the variable, and now let's go ahead with order of operations. Inside the parentheses here, I have subtraction and multiplication. Of course, multiplication has to come first. So 3 times 0 is 0. On the other side of the equal mark, we also have parentheses, and in here we have 0 plus 2, so of course that's 2. So we'll have over here 32 minus 8 times 2. Okay, now back to the left side. 4 minus 0 is 4, so 4 times 4 is going to be 16. Over here on the right, 8 times 2 is 16, so now we have 32 minus 16, and of course we know 32 minus 16 is 16. So this is a true statement, and so now we can be sure that the solution set for this equation is 0. Now let's go on to objective 2, and let's talk about equations that have no solution or infinitely many solutions. So it's possible for an equation to have no solution at all. And it's also possible for an equation to have all numbers as its solution. And both of these special kinds of equations have a name. An equation that has no solution is called a contradiction. An equation that has exactly one solution, like the ones we've been solving, is called a conditional equation because it's only true under the condition that your variable equals whatever your solution is. And if an equation has all numbers as its solution, that equation is called an identity, because no matter what you plug in for the variable, the left side and the right side will be identical. So here is example 6. This says solve and determine whether this is a contradiction, a conditional equation, or an identity. So in other words, determine if it has no solution, exactly one solution, or an infinite number of solutions. So let's solve this together. On the left, there's really nothing we can do yet, but on the right, we have 5 times x minus 3, so let's distribute the 5, and that will give us 5x minus 15. Now, you can notice at this point that the two sides are exactly alike. So you probably have a pretty good idea already that this is going to be an identity. But if for some reason you weren't sure yet and you go ahead and subtract 5x from both sides, you'll see that the x term disappears from both sides. So on the left, I'm going to end up with negative 15, and on the right, I also get negative 15. And so this is a true statement without a variable. If you lose the variable altogether, then what you've got is either a contradiction or an identity. In this case, because we ended up with a true statement with no variable, we can say for sure that this is an identity. And for an identity, the solution set is all real numbers. Now let's look at example 7. Here we have 2x plus 3 times x plus 1, and that equals 5x plus 4. Let's start by distributing the 3. That will give us 2x plus 3x plus 3, and that equals 5x plus 4. On the left side, 2x plus 3x is 5x. So over here we get 5x plus 3, and on the right side we still have 5x plus 4. Now when you get the same x term on both sides of the equal mark, you should have a pretty good idea that you're about to either get a contradiction or an identity. Let's subtract 5x from both sides and see what happens. On the left side, when we subtract 5x, we get 3. On the right side, when we subtract 5x, we get 4. So now I have this statement without a variable. 3 equals 4 is not true. And so I have this false statement with no variable. No value of x can make 3 equal 4. So this is telling me that this equation is a contradiction. And if it's a contradiction, that means that there is no solution. Now, when there's no solution to an equation, we say that the solution is the empty set. And this is the symbol for empty set. It is a circle. It looks like a 0, but it's really a circle with a line through it. And again, this symbol stands for empty set, and we only use this if the equation has no solution. Now, here's just a little caution note for us. The empty set symbol is used when there's no solution to put inside the braces, and it stands on its own. We never put the empty set symbol inside the braces. The empty set symbol is actually replacing the braces because they would have to be empty because there's no solution. Now we're going to go ahead to the next objective and talk about equations that have fractions as coefficients. The easiest way, believe it or not, to deal with fractional coefficients in an equation is to eliminate them completely with multiplication. So remember that we had the multiplication property of equality that said as long as we multiply both sides of an equation by the same value, the equation remains true. So we're going to take advantage of that here and use that to help us eliminate our denominators. To eliminate denominators, all we have to do is multiply both sides of the equation by the least common denominator, the LCD. So let's take a look at an example together. Here we have 2/3 x minus 1/2 x equals negative 1/6 x minus 2. So look at your denominators. We have a 3 and a 2 and a 6. And you want to try to think of the smallest number that all three of these numbers can go into. And of course 2 and 3 can both go into 6. 6 of course can go into itself. So the smallest number that all three of these can go into is 6. And so what we're going to do is multiply the left side by 6 and also multiply the right side by 6. So let me copy down our equation here, and now we're going to multiply the left side by 6 and we're going to multiply the right side by 6. You see how that works? And that's legal because we did the same thing to both sides. And now we're going to distribute the 6. So we're going to have 6 times 2/3 x minus 6 times 1/2 x equals 6 times negative 1/6 x minus 6 times 2. Okay, now let's go back and simplify. And the nice thing here is that because we multiplied each term by the LCD, all of our denominators are going to divide out. So notice that 6 divided by 3 is 2. This 2 times 2x gives us 4x. And here 6 divided by 2 is 3. This 3 times 1x gives us 3x. Here 6 divided by 6, of course, is 1. That 1 times negative 1x is negative 1x. And then we have minus 6 times 2, so that's going to be minus 12. Okay, on the left we have 4x minus 3x, and that adds up to 1x. And on the right we have negative x minus 12. So the next thing we want to do is add x to both sides. I'm going to come over here and do that. So we'll add x to both sides here. And that's going to give us 2x on the left equals negative 12 on the right. Divide both sides by 2 and we get x equals negative 6. Now let's take just a minute and check this solution together. So I'm going to copy negative 6 in everywhere I had an x. So 2/3 times negative 6 minus 1/2 times negative 6 equals negative 1/6 times negative 6 minus 2. And as we go back through, we should be able to take advantage of the same simplifying that we did before. Negative 6 divided by 3 would be negative 2. So 2 times negative 2 would be negative 4. Here, negative divided by negative is going to make a positive. 6 divided by 2 is 3. So that's going to give us positive 3. On the right side of the equal mark, negative times negative is positive. And 6 divided by 6 is 1, so we'll have positive 1 there. And then we have our minus 2. So now all we have to do is get a total on each side and make sure they match. Negative 4 plus 3 is negative 1, and on the right side, 1 minus 2 is also negative 1. So now we can say the solution set is negative 6. Now I did want to flip back here just a second and point something out to you. One approach to this equation would have been to get a common denominator here and actually subtract these two fractions. We did not do that. It would not have been wrong to do that, but it turns out in many cases to be more trouble to do the subtraction with the fractions than it is just to get rid of the denominators altogether. So I really want you to get some practice using this technique that I'm showing you here, so that you'll never be in a situation where you have to do subtraction with fractions if you don't want to. Now here's one that has fractional coefficients that looks a little bit different than the last one we had. You could get rid of the parentheses here by distributing these fractions. That is certainly an option. But I have another option for you, so I hope that you'll work this along with me and see a better way to do it. First, I noticed that our denominators are 3 and 5, so that tells me that the LCD for us is going to be 15. Now remember, we can do whatever we want to an equation as long as we do it to both sides. So let me copy down our equation here, and now let's multiply both sides by 15. So I'm going to multiply the left side by 15, and I'm also going to multiply the right side by 15. And now I'm going to distribute the 15. For this first term, we're going to get 15 times 1/3 times x plus 5. And for the second term, we're going to get 15 times 3/5 times x plus 2. And of course, on the right side, 1 times 15 is just 15. Now notice that we can take advantage of some simplifying here. 15 divided by 3 is going to be 5. 5 times 1 is going to be 5. That 5 times this 1 is going to give us 5. And of course, we still have our x plus 5 in parentheses. And now on the second term, we have 15 divided by 5, so that's going to make 3. That 3 times this other 3 is going to give us 9. So now we have 9 times x plus 2, and that still equals 15. So now you can see we've eliminated the denominators, and it's going to be very easy now to distribute the 5 and distribute the negative 9, and on the right side we'll still have 15. Let me just recopy here at the top of the next column, and now let's combine like terms. 5x minus 9x is negative 4x. For the constants, we have 25 minus 18, that's going to be positive 7, and that equals 15. And now we're trying to isolate the x terms, so we'll say minus 7 on both sides of the equal mark. That will give us negative 4x equals 8, and then we divide both sides by negative 4. The negative 4's will cancel, and we'll have x equals 8 divided by negative 4, which is negative 2. And now let's check that solution together. So we'll put negative 2 in place of x, so we'll have 1/3 times negative 2 plus 5 minus 3/5 times negative 2 plus 2. We want to make sure that adds up to 1. Okay, down here, negative 2 plus 5 is positive 3. So that's going to give us 1/3 times positive 3. And then we have minus 3/5 times negative 2 plus 2, which is 0. Okay, now still working on the left side, when we do 1/3 times 3, we're going to see that the 3's cancel, and we'll just have 1 there. Over here, 3/5 times 0, of course, is 0. So now we have this statement that says 1 minus 0 equals 1. We know that's true, and so our solution set is negative 2. Now here are a couple of practice equations with fractional coefficients for you to try on your own. So for each one of these, pause the video and try it, and then you can check your work with me. Here we have 1/2 x plus 5/8 x equals 3/4 x minus 6. When I look at the denominators 2 and 8 and 4, I know the common denominator is going to be 8. So let's multiply the entire left side by 8, and let's multiply the entire right side by 8. Now instead of putting a big pair of parentheses here and then having to have a separate step where we distribute, what I'm going to do is go ahead and distribute the 8 through the left side. So I'll have times 8 here, times 8 here. And then I'm going to distribute the 8 through the right side. So I'll have times 8 here and times 8 here. Now a lot of times if an equation has a whole number term, students will forget to multiply that whole number by the LCD as well. But notice you do have to do the same thing to both sides. So every term on the left gets multiplied by 8. Every term on the right gets multiplied by 8. Now let's take advantage of our simplifying here. 8 divided by 2 is 4. That 4 times 1x gives us 4x. Here 8 divided by 8 is 1. That 1 times 5x gives us plus 5x. On the right side, 8 divided by 4 is 2. That 2 times this 3x gives us 6x. And out here, minus 6 times 8 gives us minus 48. And now let's just continue combining like terms and solving the way we know how. 4x plus 5x would be 9x, and the right side is still 6x minus 48. Now we're trying to isolate the variable term, so we'll say minus 6x on both sides, and 9x minus 6x will be 3x, and that's equal to negative 48. Divide both sides by 3, and that's going to give us x equals negative 48 divided by 3, which is equal to negative 16. Now we can check that negative 16 relatively quickly. 1/2 times negative 16 plus 5/8 times negative 16 equals 3/4 times negative 16 minus 6. Let's go through here and just simplify. Negative 16 divided by 2 is negative 8. 1 times negative 8 is negative 8. On the second term, negative 16 divided by 8 is negative 2. 5 times negative 2 is negative 10, so I'm going to write minus 10 here. On the right side, negative 16 divided by 4 is negative 4. So 3 times negative 4 gives us negative 12. And then we have our negative 6 just sitting out here. So negative 8 minus 10 is negative 18. On the right side, negative 12 minus 6 is also negative 18. So that solution is correct. And we could put our negative 16 inside the curly braces. Here's a second one that you can try on your own. And now I'm going to work it with you. So I see that we have a 1/4 and a 2/3. So that tells me that our LCD is going to be 12. Let's take this equation and let's multiply both terms on the left by 12, and let's multiply the term on the right by 12. So I'll put times 12 here, times 12 here, times 12 here. That's just saving us the step where we put the whole left side in parentheses. So we've already distributed the 12. Now we simplify. 12 divided by 4 is 3. That 3 times this 1 is 3. So we'll have 3 times x plus 3. And then here 12 divided by 3 is 4. This 4 times this 2 is 8. So I'll have minus 8 times this parentheses. And on the right side, negative 2 times 12 is negative 24. Now let's distribute the coefficients here. 3 times x is 3x. 3 times 3 is 9. Minus 8 times x is minus 8x. And minus 8 times 1 is just minus 8. Still negative 24 on the right side. Now let's combine like terms on the left. Positive 3x and negative 8x together make negative 5x. Positive 9 and negative 8 together make positive 1. Okay, now let's continue isolating the variable term. We'll say minus 1 on both sides of the equal mark. That will give us negative 5x equals negative 25. Now we want to isolate the variable, so divide both sides by negative 5. The negative 5's on the left side will cancel each other, and we'll get x equals negative 25 divided by negative 5, which is positive 5. And now we can check that solution. So we'll just put our positive 5 back inside the original equation. So 1/4 times 5 plus 3 minus 2/3 times 5 plus 1 is supposed to be equal to -2. Let's work the addition inside each pair of parentheses. 5 plus 3 is 8, so we're going to get 1/4 times 8 minus 2/3 times 5 plus 1, which is 6. And now let's simplify. 8 divided by 4 would be 2. So this 2 times this 1 would make 2. And here 6 divided by 3 would be 2. So this 2 times this 2 would be 4. And we know that 2 minus 4 is -2, so that's true. And that tells us that 5 is the right solution. Now, I've gone through the checking process in detail with you now on several examples, so I hope that you're forming a good habit of checking your work. I've seen lots of students lose lots of points because they did not check their work. I know that you're not going to check every single time, but you need to make a habit out of checking, and you need to check while you're doing your homework, because once you get on a proctored test, you won't be able to get the computer to tell you if you're right or wrong. You'll have to know how to check that yourself. So it's a really good habit to always check your solutions, and besides that, it builds your number skills and it just makes you even less likely to make careless errors.